working on the same note sheet, the transformation note sheet in Notability. Hopefully you got an opportunity to open that up and just to, refresh where we were. Yesterday, we talked about all of these parent functions, talked about their domain, their range, their name, and did some cahoots to try and get familiar with those. And we really want to get those at our fingertips. So again, if I say, all right, everybody, we're talking about the absolute value function, you guys know we're talking about that one that looks like a V, okay? We then did some transformations of those up, down, left, and right. If we subtracted something internally, that moved it to the right. If we added something externally, that moved it up. Likewise, if we add internally, that was left. So internal is left and right, and external is up and down. All right, well, after our warm up today, hopefully you guys realize that today is going to be about reflections. So what happens with these parent functions, and actually with any function, is that it gets reflected over an axis when you multiply by something. So adding and subtracting something shifts it horizontally or vertically. When you multiply by something, that causes a reflection. So here we are multiplying by a negative externally, as opposed to this is internally. Okay, so first recognize that this is an external multiplication. This is an internal multiplication because they do different things. If it is externally multiplied, that reflects over the x-axis. Okay, again, if the negative is multiplied externally, if it's outside of the absolute value or outside of the radical or outside of the parentheses, if it's external, it reflects over the x-axis. If it's internal, it reflects over the y-axis. And as long as we're here, we have a couple of other rules that I'm going to write down. We're not going to practice much today, but we will tomorrow. So if we have a number, not a negative, but a number C that's greater than 1. So C would be a number, like if it's 3 or 5 or 100, something bigger than 1. What that does is it makes the graph more narrow. The larger the number, the more narrow it gets. So if C is a really big number, your graph gets really, really narrow. If C is a smaller number, not so much. And in fact, if C gets real small, like between 0 and 1, so like a fraction of 1/2, or let's say 1/10, okay, so something between 0 and 1, then that makes the graph really wide. So that would be our leading coefficient. Now, looking at those rules, you might say, well, wait a second, what if it gets, what if C gets then less than 0? If it gets less than 0, then it becomes negative, and we have this idea, we have the reflection. And so then it's a reflection and makes it wide or narrow, depending on what its value is. All right, any questions yet? All right, so we're going to then apply these rules to some of our parent functions. So I'm going to do, ultimately, I want to graph this. So I want to graph g of x, where I'm multiplying by a negative internally, and I'm adding 2 externally. So looking at my rules, and I'm not going to go back up to them, but you have them listed. If I multiply internally, that reflects over the y-axis, because the negative is inside of the radical. If it was out here, it would reflect over the x-axis. So if it's internal, it reflects over the y-axis. And then the plus 2, that's going to move the graph up 2. So remember, my parent function is the square root of x. So I'll graph that over here just so we have an idea. Hopefully you remember what the square root of x looks like. It's this guy, okay? That is the parent function. So I'm going to take that function and copy it and paste it over here. And what I want to do now for that is reflect it over the y-axis like we were just doing. So if I take it and reflect it, this is my mirror now. So I'm reflecting it over the green mirror. It's going to look like that. There is my reflection over the y-axis. And now I have to move it up 2. So I'll move it up 1, 2. And that green graph is my final answer. So I should, of course, erase the red because now that green is the graph of that function. So again, I took the square root of x, I reflected it over the y-axis, and then moved it up 2 to get my green graph. All right, I'm going to graph a couple more. So I'm actually going to borrow these graphs down here. I'm going to erase this h of x, and I'm going to change the function, okay? So why don't you guys, and again, this is, just in relation, it's so down and to the left in your notes. So let's say h of x is equal to the opposite of the absolute value of x minus 2 plus 1. So lots going on in this graph. We've got a reflection because we are multiplying by a negative. We have the minus 2 inside. That's going to move the graph to the right. We have the plus 1. That's going to move it up. And you might be asking yourself, well, wait, which one do we do first? You follow the order of operations. So we know that our parent graph is absolute value of x. And in using the absolute value of x, according to the order of operations, I'm going to move it in this order now. I'm going to first do the inside stuff. So I'm going to move it right 2. Then I would do the multiplication. So that's going to reflect, that's external. So that's going to reflect over the x-axis. And then the last thing I'm going to do is move it up 1. So I'm going to do them in that order. So I follow the orders of operations. I'm going to take the absolute value function, move it to the right 2, reflect over the x-axis, and then move it up 1. So let me start with our parent function, the absolute value. So there it is. I'm going to move it to the right 2. So I go 1, 2 to the right. Then I'm going to reflect over the x-axis. So now it's facing downward, of course. So I reflected it, and I'm now the green graph. So I'm going to erase the red one. And then I have to move it up 1. And that would be my final answer. All right, so I could say, what's the domain of this graph? Well, the domain is all real numbers. What is the range of the graph? Well, the range is going to be everything from negative infinity to positive 1, inclusive of positive 1. If I said, what's the interval where it's increasing all over here. So from negative infinity to 2, because we do those intervals along the x-axis. So we can add in some of those other questions that we were talking about long ago. All right, let's do one more together here. So I'm going to, again, change this function in the lower right, that j of x. I'll change that. So let's say j of x is equal to negative x to the third minus 2. All right, so my parent function is x to the third. And I have a couple of transformations I'm going to do in order. I'll do this negative inside. That's internal, so that's going to reflect over the y-axis. And then I'm going to do the minus 2. That's going to move it down 2. So I'm going to take x to the third, reflect it over the y-axis, and move it down 2. So here we go. X to the third looks like that. Okay, now, hopefully you can see, like, this is why it's important to get a basic idea of what our parent functions look like. Reflected over the y-axis now looks like the green graph, so I will erase the red one. And then I'm going to move it down 2. So I'm taking actually this center point here because it goes to the origin, and that's the easiest one, I think, to recognize. I'm going to move that center point down 2. So I really focused to make sure that went through negative 2. And then that green graph now is my final answer. All right, so here is something that would be on your homework. So in the Delta Math, we're doing transformations. This is the parent function. So it gives us the parent function. And it's the parent function is the cube root of x. And we need to figure out, what do these transformations do? Well, remember, the plus 4 moves the graph to the left 4. And then the minus 1 moves it down 1. So I'm going to grab the middle of the graph. I'm going to move it to the left 4. I think. There we go. 1, 2, 3, 4. And move it down 1. And that is what I think my answer is. So I'll submit that answer. Looks good. All right, now this one's a little different. The difference is this negative sign here. That's going to be a reflection. So 2 to the x is what's given. That is our parent function. So in order, I'm going to reflect it. That's external, because if it was internal, it would be up in the as the exponent. So that negative is external. So that's going to reflect it over the x-axis. And then I'm going to move it down 1. So to do a reflection, remember, I need to just take these points and reflect them over the x-axis. So just like we were doing before, I know that this point right here is 2 above the x-axis. I can take that and just drag it 2 below the x-axis, and it will move all of them at the same time. So I did my reflection over the x-axis, and then I will move it down 1. So I'm going to move the graph down 1. So the green part is how I move it up, down, left, and right. Submit that answer, and looks like we're on a roll here. So just to do one more reflection, this is internal now. So internal is going to reflect over the y-axis. So I'm taking this cube root of x. I'm going to reflect it over the y-axis. So I'll just take a point and drag it over the y-axis. All right. Any questions on this before I shut it down?
How'd you get that last one to flip?
if you just grab any one of the points, it will reflect. So let me pull a new one up. So if I want to flip this over this is going to be over the y-axis, I'm sorry. So I grab any of the blue points and I want to reflect them over the y-axis. And you can do any one of them and it will move all three of them at the same time. So I can see that this one is 1, 2, 3 spots away. So I'm going to move it 1, 2, 3 spots away. And so it reflected all of them at the same time.
Okay, thank you.
Now, yeah, now I have to move it up 3. So I grab the green one and I move it up 3 and don't move it over, just up 3. So yeah, you got to be a little careful with these, but then there would be my answer. All right, any other questions?